Okay, so this is just a continuation of my previous lecture where I'm talking about chapter 16 of A Student's Guide to the Great Physics Texts. There we had talked about how Pascal was drawing out the consequences of the fact that air has weight. Specifically, our atmosphere, comprised of air, has an enormous amount of weight, although a limited amount of weight because our atmosphere is limited in size. In other words, we live under an ocean of air. We finished off by talking about how air is compressible. So just as a great pile of wool has a higher density at the bottom than at the top due to the weight of the wool that rests above it, so too the density of air is higher near the surface of the Earth than in the upper atmosphere. That's due to the weight of the air that is above it. And he also mentions another thing. So I think if our numbering is correct, we're on point 7 here. So let's draw another consequence here, is that just as if we cut a cube of wool from the bottom of the pile, from the bottom of a pile of wool, and set it on top, it would expand. So too, if we take a balloon full of air, if we take a balloon that is full of air near Earth's surface or near sea level and bring it to the top of a mountain, it will expand. It's the same kind of reasoning. So you bring a balloon to the top of a mountain, it will expand. So this is the last of these consequences that Pascal derives. And he points out that these are all 7 of these that we've gone through are logical consequences of the assumption that weight has air. But, he goes on to say, you can empirically test these. So these 7. Above I just talked about 1. In the previous lecture I talked about 6 others. These 7 are logical consequences of air having weight. Okay, so he's doing this on a strictly logical basis. But he mentions that one can empirically test this. One can empirically test these if you want to. So we can empirically or experimentally test whether these things are true. But here is where, this by the way is on page 202 of the text. Here I think is where he makes an interesting statement that has to do a bit with the philosophy of science. He says, these are rational consequences or logical consequences of air having weight. We can, however, empirically test these, but if our tests failed, so for example, if we took a balloon at sea level and we brought it up to the top of a mountain and we found that it did not expand, that is, if this test failed, he says, I would still be correct. I would just claim that I didn't go up high enough. So if the experimental test failed, then I would still be right, he says. I would still be correct. I would just say that I didn't go up high enough in the mountain. So this is an interesting comment that he makes because we kind of think of science as this empirical enterprise, and that's what Pascal begins to sort of present himself as at some point, as this hard-nosed experimentalist that's saying whether or not things are consistent with experiments. And here he's really providing a caveat. He's saying if our if our experiments fail, we can still maintain this theory. We can just say that the theory, our experiments weren't precise enough, or we didn't test them under the right circumstances. I think this raises some profound questions about how science works that I suppose we can talk about another time, but I just want to raise that at this point. Nonetheless, he did do the experiment. He did carry out this experiment. There's a famous paper. I've had students read this paper in the past. It's an experiment that he did on the Puy de Dome. It's a mountain near Paris, I believe. He did do the experiment. What did he do? He took a balloon that was kind of a flaccid balloon. I'll draw a little flaccid balloon, not pumped up very high. A flaccid balloon. And then he took it one day hiking up the Puy de Dome, this tall mountain. And he found that when he carried this balloon up to the top of the mountain, which he mentions is 500 fathoms tall. I will let you look up how tall 500 fathoms is. But when he found that when you took it up the mountain, it in fact grew stiff and round. And when he came back down, the balloon became flaccid once again. Why is that? Well, because there's a little bit of air in here, and there's a little bit of air in it here. The amount of air doesn't change. What's different is that down here, the atmospheric pressure is high. Remember, we live under this huge atmosphere of air that's pressing down. So down here, the atmospheric pressure is high, so it's compressing the balloon. But up here, the atmospheric pressure is low, so it doesn't compress it nearly enough. So this is the experiment that he carried out. I forget the year it was, sometime in the mid-1600s, that in fact did verify this kind of these claims that he was making, and it really strengthens his claim that the air has weight, and the weight of the air is responsible for phenomena such as this. So I will stop here, and next time I will go on to talk about a few more of his